So next point of the states of matter, we are talking about the surface tension. So attractive force increases, surface tension increases. And next one is temperature increases, kinetic energy increases in inversely proportional to intermolecular forces, right? So when we increase the temperature, surface tension decreases or intermolecular force decreases, and surface tension also decreases, right? Because they are inversely proportional. So increase in temperature decreases the surface tension, temperature decreases, surface tension increases, right? So they are inversely proportional to each other. So viscosity, it is the nothing, it is property of the liquid only. So viscosity is another property of liquid. One of the characteristics property of liquid. Properties of liquid. Viscosity is the measure of resistance to flow. So what it gives? It resists the flow of liquid. So it is a measure of resistance to flow which arises due to the internal friction. Which arises due to internal friction. Internal friction between layers of fluid as they slip past one another. As they slip past one another. So this is the internal resistance between the molecules while they are flowing. While liquid flow. While liquid flow. Next point is a strong intermolecular forces between molecules hold them together. Resistance movement of layer past one another. So resistance movement is higher. Right. So a strong intermolecular forces resist the liquid. Strong intermolecular forces resist the liquid flow. Right. Next one is when a liquid flow over a fixed surface, the layer of the molecule in the intermediate contact of the surface is stationary. Right. So when it is flowing from a fixed surface, then the intermediate part is stationary. The velocity of upper part increases as the distance of layer from the fixed layer increases. So velocity of liquid is increases. Velocity of upper layer. Upper layer increases as distance of layers from the fixed surface increases. From fixed layer increases. Right. Next is this type of flow in which there is a regular gradation of viscosity in the pass from one layer to the next is called laminar flow. Right. So there is regular gradation of velocity. Regular gradation of velocity in passing from one layer to the next. One layer to next is called laminar flow. Which called laminar flow. Right. So you can see the diagram for that. This is u plus dv. Velocity upper part is more. This is initial velocity. This is u minus du. Right. So this is the area of the plate A. Right. Whose width is given by dz. Right. So right up to this point, then I will give you the next one. Let's derive the viscosity formula. If velocity of the layer at a distance dz is given by du, so dz at du, so that is called velocity gradient. So next is velocity gradient. So it is given by du by dz. If force is required to maintain the flow of layer, the force is proportional to the area of the contact. So next will be force is directly proportional to the area of the contact. By applying these two equations, what we get, F is directly proportional to A du by dz. So by removing this proportionality, we can get F equal to eta A dB by dz, right? So this eta is nothing but it is the coefficient of viscosity. So what is eta? Eta is coefficient of viscosity. Coefficient of viscosity, right? So viscosity is the force when velocity gradient is unity and area of contact is 1. So if you want to calculate the eta value from here, then we can use this equation. Eta will be equal to force upon area into du by dz. Right. In this way, we can derive the unit of viscosity. So it will be Newton second per meter square. And this is also called as Pascal second. Right. It also measure in pose. Hold for a second. Huh? So you can use this relation for finding the numerical. 1 pose is equal to, this is the conversion, 1 gram per centimeter per second. Next one is 10 raised to minus 1 kg per meter per second. Right. So next point is greater the viscosity, more slowly the liquid flow. So when eta is greater, so liquid flow the slowly. Flow of liquid is slow. Right. Next is this, which show the more viscosity, right? It show the hydrogen bonding and van der Waals forces. Hydrogen bonding and van der Waals forces are strong enough to cause high viscosity. Enough to cause high viscosity. Right. Glass is extremely viscous liquid, which is so viscous that many of the properties resemble solids. Right. Viscosity of liquid decreases as the temperature rises. So write the next point. So as temperature increases, viscosity decreases. So they are inversely related. Because of high temperature, molecules are high kinetic energy can overcome the intermolecular forces to slip past the one another. So in this way, we have completed the states of matter. Then we will study the next chapter. So right up to this point.